so we're starting with our first function. My function is negative x. My inequality says x is less than negative 1, so we're going to start with negative 1. Would it be open or closed at that negative 1? Open. Okay, so I'm going to put myself a little note here. Maybe. And then what are some numbers that are less than negative 1? Yeah. Okay. And so when we plug those in, there's already a negative in front of our x. So when we plug in that 1, it's a negative 1, which would turn it positive. And then we plug in a negative 2, it would be a negative 2, which would also turn it positive. And then the same thing for 3 and 4. So when we graph, when you do this, make sure that when you're plotting that open point, you can clearly see that it is open, because we're going to need to see that for our domain and range. Negative 2, positive 2. That's going to be a closed point. The only time you have an open point is if you have a starting or a stopping point. Every other point is going to be closed. And then if I'm just saying x is less than negative 1, can I extend it continually? Okay, we don't have that double inequality, so there is no end point. So we're just going to extend past those and put our arrow. Then we can do the second piece. This function is just negative 1. My inequality here. Try that one more time. Says x is greater than or equal to negative 1, so I'm going to choose that negative 1. Is it going to be open or closed at that one? Closed. And then give me some numbers greater than negative 1. And then since my function is just negative 1, is there anywhere to plug those x's in? No, so every y value is just going to be negative 1. All right, so I'm going to plot the point negative 1 with a closed circle. 0, negative 1, 1, negative 1, 2, negative 1. Can I extend past that? Yes. Okay, we start at our starting point. We continue through because there's no end point with that inequality. And so our graph should look something similar to that. When we have these on the quiz, I'll be looking for the graph and then all the pieces to it. So next what I want you to do is domain, range, increasing, decreasing, and constant. Okay, now that we have it graphed, go ahead and list that domain, that range, your increasing, decreasing, and constant. It is. I included it. Yeah, I know. Okay. I just include everything in, like I started. Huh? I did that. Okay, did you start with this one? Show me your negative 1. You have to do this one. You have to start with this one. The positive one. So, negative 1. Negative 1. You start with this one. You start with one. So you start with that number. That's your x. So you put it in the x. And you press it to the x with the plus and all of my values. This is the difference in this one. This one has an x on it. So this one, because we have an x, we actually plug those numbers in. And so here I don't have an x to plug that in. So all of my values will be that same. Yeah, so if you think about it, f of x equals negative 1. What do we say? F of x always just doesn't matter. That's with the other side. So it has an extra plug-in number then if it doesn't. It's just that number consistently. Is everybody ready? So when we do these, I start from the left to right. So I look at this first piece. Is that going downstairs or upstairs if I go from left to right? Yeah, so that would be decreasing. Okay, and this one is just straight across. So that's closed. So we would have no increase. All right, let me make some room real quick. Let's do it over here. All right, start with our domain. Left to right. Do we go as far left as we can? Yes. And then we're coming across, and then does everybody see we have a hole at the blue one? However, this hole in my blue piece is covered by that closed hole in the green piece, so I can keep going, right? So my domain is going to keep going all the way to the right, which would give me negative infinity to positive infinity, right? Okay. Even though the blue piece has a hole in it, the green piece covers that hole, so therefore it's going to be all reals. Now let's be careful with our range here. Bottom to top, what is the first y value that I touch? -1. And it's just -1, right? So that's that one single number. We're going to put our little braces around it. Maybe, if my pen will let me write properly. And then we're going to jump because we have a hole. We have an open spot right here, and we are at -1, but we're open until we get to 1. Am I equal to 1 there? No, so I'm going to use a parenthesis. And then am I represented everywhere above that? Yeah. So that would be 1 to infinity. Now remember, with your increasing, decreasing, and constant, we may not have all three. We may only have one of them. We may only have two of them, okay? Sometimes we have them all three. We're just going to go piece by piece with our graph, starting with the blue part. Is this one going downstairs or upstairs? Down, so that would be decreasing, and we're decreasing from negative infinity to -1. Whoops, that's not a 1. Okay. And then the next piece, my green piece, that just goes straight across, which means it is constant from -1 to infinity. And so in this case, we don't have any increasing parts of our graph. Are we kind of okay there? All right, I want you to work on 4. Graph both pieces. When you're done with that, go back and do your domain, your range, increasing, decreasing, and constant. My function is -x. My restrictions are going to be numbers that are less than or equal to 0. Remember, your starting point is always the number that's in the inequality, which is what here? 0. Am I going to be open or closed at that point? Closed. And then I need a few numbers. Let's go with 3 that are less than 0. -1, -2, and -3. All right, what is a -0 going to give me? 0. And a -1 is, a -2 is 2, and a -3 is 3. So we're going to go closed at 0, 0. And then every other point is also closed. So -1, 1, -2, 2, -3, 3. And then we go from our starting point. We extend past those dots because we don't have an ending point. We put our arrow. Then we're going to do the second part of this function, which is x squared. My starting point, again, is 0. Is it going to be open or closed at this second piece? Open. Okay. And then I want numbers greater than 0, so I'm going to choose 1, 2, and 3. And then my function says to square it. Well, 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Now, when I go to do 0, 0, it says I need an open point, but didn't I already close in 0, 0? So that really isn't going to change anything. I still have that point there. That's my starting point. And then we do 1, 1, 2, 4, 5, 6, 7, 8, 3, 9. And we're going to go through those points and keep going. So your graph should look like that. We've covered up any open pieces. And then, so what do you think about your domain? Everything. We don't have any holes anymore because we've covered them up. My range, what is the first y value that I touch? 0. Am I equal to 0 on my range or not? Yes, so we're going to do a bracket. And then it goes forever up, which takes me to infinity. And then we can go through with our increasing, decreasing, and constant. Starting with the left side, what is the blue piece doing? Decreasing from, okay. And then the green piece is increasing from 0 to infinity. And then we don't have any constant areas.